Okay, let's jump right into this astonishing discovery. Thermophilic ice fish that literally defy our conventional rules of
Yep.
physics in the Arctic. Imagine fish maintaining internal temperatures over 200 degrees in freezing water.
Wait a minute. You're telling me these fish are literally like mini furnaces, even when the water is well below zero?
Exactly. Right. So Dr. Elena Vasquez, a marine thermobiologist with a doctorate from Woods Hole, spent 5 years in Arctic waters and discovered not only these thermal marvels, but also 17 new cold-adapted species. Talk about groundbreaking.
That's wild. And the equipment used, infrared cameras, underwater thermal probes, they were recording temperature spikes that shouldn't even be possible, right?
Absolutely. During the mission aboard the NSF-funded Polar Dawn, they encountered readings like Xingquan DGF, then later soaring to over Qiaoquan DGF. It's like nature was rewriting the book on thermodynamics.
Yeah. I mean, underwater in Jiaodegisi water, these readings challenge everything. Protein stability thresholds, heat control, you name it. Isn't that a game changer?
It really is. The fish not only maintain extreme interior heat, but have multiple thermal zones across their bodies. Their extremities can be near freezing, while their core organs, get this, blaze at temperatures you'd expect nowhere near water like that.
Mm-hmm. That's like having a built-in temperature control system that's insanely sophisticated. And they even modify their surroundings, sort of like creating thermal pockets.
Exactly. Underwater footage revealed these fish generating currents that keep ice at bay in a 50-foot radius. It's almost as if they're terraforming their underwater ecosystem, an environmental modification that should be impossible for a single species.
Wow, talk about a natural air conditioner. But don't you think it sounds a bit over the top? I mean, is it really plausible for biological systems to have such precise control over quantum thermal regulation?
That's a fair point, but Dr. Tanaka, the thermodynamics expert on the team, confirmed through multiple verification tests that the measurements were spot on. They even had independent specialists double-check everything.
Right. So these findings didn't just leave everyone scratching their heads. They also sparked discussions linking biological processes to quantum phenomena, which is, seriously, edge-of-your-seat stuff.
Exactly. The connection to quantum biology really adds a whole new frontier to the research, bridging physics, biology, and even engineering.
Speaking of engineering, isn't it fascinating that these thermal adaptations could inspire innovations like advanced electronics cooling systems or improved thermal management in buildings and even spacecraft?
Absolutely. The potential applications extend so far, from revolutionizing treatments for burns and frostbite in medicine, to improving organ preservation techniques and even redesigning thermal management in high-tech industries.
It's like nature's own blueprint for managing extreme temperatures, just in the most unexpected ways. And what about their collective behavior? I heard something about these fish coordinating their thermal output collectively.
Yes, indeed. These schools of fish essentially become a living thermal regulation system. They share the heat load, ensuring that the overall environment around them stays just a bit warmer.
Mm-hmm. That sounds almost like a social, collective intelligence focused on temperature control. It's fascinating how their behavior not only supports individual survival, but also benefits the entire ecosystem.
Right? And this ecological impact is incredible. By creating these warm pockets, they enable other species, ones that are usually sensitive to extreme cold, to survive in what would otherwise be barren frozen waters.
That's a total game changer for Arctic ecosystems. Imagine if these biological heaters could gradually reshape food webs and biodiversity patterns as climate change progresses.
Indeed, this discovery opens up a whole host of questions regarding ecosystem development and evolutionary biology. How did these fish evolve such counterintuitive metabolic adaptations? And what does it mean for the future of life in rapidly changing polar regions?
Yeah. And then there's the whole controversial aspect with the scientific community. Their initial attempts to publish these results faced major pushback, right?
Yep, exactly. Their findings were initially rejected by some top journals because reviewers simply couldn't accept data that blatantly clashed with established thermodynamic laws. They had to conduct extra tests for credibility.
Which is quite ironic since nature often defies our assumptions, isn't it? It pushes the boundaries of what we think is possible.
Right on. It's like nature saying, look, we're not here to follow your rules. And now, with independent verification and support from quantum physics circles, the debate has shifted towards acceptance and, excitement about this new research avenue.
I find that super refreshing when science challenges itself and grows. And the interdisciplinary aspect, bringing together marine biologists, biochemists, thermal experts, it really highlights collaboration at its best.
Absolutely. The expert team aboard the Polar Dawn, including Dr. James Chen, Dr. Sarah McKinnon, and Dr. Yuki Tanaka, demonstrated how blending expertise from different fields can, open up groundbreaking insights.
And I imagine that these findings are also nudging us toward innovative capture and conservation methods, right? I heard traditional nets wouldn't work because they heated up too fast.
Yes, the team had to develop, new capture methods, even thermal-resistant aquariums, to safely transport these fish. It's a perfect example of adapting our techniques when nature throws us a curveball.
That's both inspiring and humbling. There's so much we can learn from these creatures, especially regarding survival in extreme conditions, which might even inform future space exploration technology.
Absolutely. Inspiring stuff indeed. By mimicking the fish's thermal regulation, we might, fundamentally change our approach to both engineering and medicine. From designing safer spacecraft to developing novel cancer treatments through targeted heating.
It really gives a new meaning to thinking outside the box when it comes to biological adaptation and technological inspiration.
Exactly. The mixing of biology and quantum mechanics in these fish's adaptation pushes us to, sort of, re-examine the boundaries we once thought were unmovable in science.
Yet, while the evidence seems overwhelming, do you think there's still room for skepticism? After all, it upends so many established principles.
Oh, definitely. A bit of healthy skepticism is natural. But the rigorous multi-layered verification, plus the support from independent research teams, really bolsters the case. It reminds us that nature often has, surprises that no one could predict.
I agree. Sometimes, it's those very surprises that ignite the next leaps in scientific progress. And honestly, who wouldn't be excited about a future where our understanding of life and thermal energy is taken to a new level?
Right. And with further expeditions planned to study these fish, tracking their migration and reproductive cycles, we're set to witness even more revelations, possibly reshaping our ecological and technological landscapes.
Yeah. It seems like we're just scratching the surface of what nature can teach us, especially when it comes to seemingly impossible adaptations. The implications for medicine, environmental management, and engineering are truly stunning.
Absolutely. It's a wonderful reminder that sometimes the most mind-boggling discoveries force us to question, challenge, and ultimately expand our very definitions of what life can do.
Well, here's to more revelations from the frontiers of science. It's been incredibly enlightening chatting about these thermophilic ice fish and how they're, well, literally defying physics.